Hello everyone, I am Swarnadipta Ghosh from the Indian Institute of Space Science and Technology. Today I will briefly present our recent work published in IEEE Transaction on Antennas and Propagation on single feed dual polarized dual beam impedance modulated metasurface antennas. Conventional phased arrays are often bulky and multi-layered, and they require more complex feeding and phase shifting networks, especially for polarization control. In contrast, modern radar, sensing, and 6G FR3 band systems demand compact, low-profile antennas capable of multi-beam and multi-polarization operation. To meet this requirement, we use a modulated metasurface antenna composed of a non-uniform arrangement of scalar unit cell synthesized using a periodic sinusoidal impedance modulation scheme. The antenna is excited by a TM mode surface wave launcher enabling on-surface control of aperture fields with a simple and low-loss feeding architecture. Our design follows a systematic methodology. We start with unit cell optimization and dispersion analysis, then perform a phase 2 impedance transformation. Based on this, an N by N surface impedance map is generated and implemented using automated HFSS and Python scripting for full wave simulation. From the analytical impedance relation, we show that the basic modulation produces a split radiation pattern with a central null. To overcome this, we introduce a phase correction factor which removes the null and enables clean radiation pattern. For dual circular polarization, we use the sum of mutually orthogonal spiral phase profiles. Similarly, dual linear polarization is obtained using sum of mutually out of phase linear phase functions. Using this approach, we designed the dual beam metasurface antenna supporting both linear and circular polarizations. The required beam directions and polarization states are directly controlled through the impedance modulation functions. MTS and beam specifications are mentioned particularly in this slide. The metasurface is implemented on the Rogers 5880 substrate using a precise phase-to impedance mapping to accurately control the beam pointing and polarizations at 25 GHz. The proposed antenna achieves a peak gain of about 19.2 dBi and an axial ratio bandwidth exceeding 18% and the side lobe level below minus 18 dB, resulting an improved gain bandwidth performance of dual polarized dual beam operation is mentioned in this particular work. In summary, the work presents a general and scalable framework for designing single feed polarization agile multi-beam metasurface antennas. The proposed approach is well suited for reconfigurable intelligent surfaces, compact radar systems, and next generation wireless systems. Thank you for the attention. I hope you find this work useful. Thank you.